Let's just dive right into this explainer. Picture this. You are stepping away from the sterile, perfectly climate-controlled laboratories of a modern university and walking right into the heavy, humid, salt-tinged air of the Kochi backwaters in India. Today, we're unpacking a really fascinating story about the clash and ultimately the beautiful convergence of modern science and ancient tradition. So out in this region, cheap, mass-produced fiberglass boats are pretty much taking over the coastline. But tucked away, there is an old boatyard where an 84-year-old man named Joseph Matthew is keeping a 68-year-old tradition alive. He is literally one of the very last traditional wooden boat builders in India, and honestly, his process is going to completely change how we think about engineering.
To truly get the genius of what's happening down in Kochi, we're going to look at this entire story through the eyes of a visiting marine engineering student. Put yourself in her shoes for a second. You've spent years grinding away, studying fluid dynamics, structural stress equations, computer-aided design. You rely heavily on advanced software to tell you if a hull is actually going to float or if it'll capsize. And then you meet Joseph, a master builder who doesn't use a single piece of software. In fact, he kind of defies almost every conventional rule in your modern textbooks, and yet his vessels navigate the rough Arabian Sea flawlessly. So what happens to your entire academic worldview when you witness that firsthand?
Section 1. An unexpected classroom, when theory meets tradition.
So, our engineering student walks into this yard, right? And she's fully expecting modern manufacturing techniques, strict safety protocols, maybe some blueprints pinned to massive whiteboards or laser-guided cutting tools. But instead, she gets hit by this jarring yet totally beautiful reality. It's just the overwhelming, earthy scent of seasoned teak, ungili wood, and fresh sawdust. There are no blueprints here, like literally none. No computer screens. It's just 84-year-old Joseph Matthew, a man who relies entirely on his own memory to shape these massive, complex vessels. For someone trained in a sterile academic environment, it is an absolute sensory overload.
And you realize pretty quickly, it's not just about memory, it's about legacy. The student is basically stepping into a living history book. 100 years ago, Joseph's grandfather was swinging the exact same tools, specifically this incredibly heavy wooden mallet, to shape these hulls. Fast forward, and 68 years ago, Joseph himself started his own boat-building journey, just soaking up all this unspoken knowledge from his forebears. Present day, he stands as one of the very last of his kind in Kochi. For our student, the realization hits her. She isn't just watching a mechanic at work. She's witnessing 4 generations of unbroken, continuous data compiled not on a hard drive, but right there in human hands.
Section 2. Patience before the sea, the science of selecting wood.
Think about how a modern engineer builds anything. First, they test the materials using moisture meters, stress gauges, microscopic analysis, the whole shebang. Joseph, on the other hand, just walks the shoreline before dawn. He's got these huge stacks of seasoned teak and ungili wood that have literally been sitting and drying for years. Instead of plugging in some fancy machine, he just gently taps the timber with his hand. He is listening for acoustic resonance. He uses hands and his ears as these highly tuned sensory metrics to figure out if the internal moisture content is right and if the structural integrity of the grain is actually ready to take on the ocean.
And Joseph explains this whole process to the student with this absolutely incredible phrase. He says, "Wood must first learn patience before it learns the sea." I mean, think about that from a pure engineering standpoint. It's a massive aha moment for our student. She realizes Joseph isn't just trying to be poetic here. He inherently understands that organic materials hold kinetic energy, they expand, they contract, and if you rush that curing process, the material is going to fail under the immense hydrostatic pressure of the ocean. He absolutely knows material science, he just uses a totally different vocabulary to describe it.
Section 3. Engineering without blueprints, intuitive physics.
Now watch as our marine engineering student has her entire paper and equations methodology completely stripped away. We're looking at the traditional edition of the engineering process here. Step 1, Joseph shapes the keel, the absolute backbone of the ship, using only hand saws, chisels, and his own memory. Step 2, he raises the wooden ribs, naturally mimicking the skeleton of a great fish. That is an amazing example of biomimicry long before it ever became an academic buzzword. Step 3, he bends these incredibly heavy wooden planks over steam, knowing exactly how much thermal energy is needed to make the wood pliable without snapping its internal fibers. And finally, Step 4, sealing every single joint with natural fibers and traditional waterproof resin. No cold calculations, it is pure, tactile interaction with the elements.
So here's the absolute game changer. Joseph isn't just guessing out there. What he's doing is practicing what we can call intuitive engineering. It's this mastery of balance, buoyancy, and strength through physical feel, relying on centuries of practical, hands-on knowledge instead of just grinding out mathematical equations. Our student realizes, wait, Joseph is doing complex calculus in his head. He intimately understands weight distribution, center of gravity, and fluid dynamics. He just didn't learn it in a stuffy lecture hall. He learned it through generations of trial, error, and literal survival. And make no mistake, the stakes for this kind of intuitive engineering are off the charts. Joseph looks at the student and says, "The sea is the only examiner that never gives second chances." For a university student who's used to, getting a C on a midterm or maybe begging a professor for an extension, that is a chilling, super sobering translation of his wisdom. Out there on the water, a miscalculation in buoyancy or failing to properly seal a joint doesn't just mean a bad grade. It means a loss of livelihood, or worse, a loss of life. The ocean is the ultimate, completely unforgiving test.
Section 4. The final launch. A boat with a soul. But this engineering, it isn't just about making a piece of wood float. It's deeply, deeply personal. The student watches as this young fisherman arrives at the yard, bringing literal years of his life savings to buy his very first boat. Joseph doesn't just hand him some standard off-the-shelf product from an assembly line. No, he interviews the young guy. He asks him specifically about the local tides, exactly where he plans to fish. Then, Joseph customizes the curvature of the hull to match those specific water conditions. The boat is sanded by hand until it's perfectly smooth, and when it's finally ready for the water, the fisherman names it after his mother. I mean, that is user-centric design at its absolute finest, right?
Because Joseph's whole philosophy is that a boat should meet the sea like an old friend. That one thought guides every single sanding, cutting, and sealing decision he makes. He isn't out there fighting the water, the way modern, rigid powerboats often try to do. He's designing a vessel to work in total harmony with the environment. It's a relationship, not a conquest. Our students see that this approach to design ensures not just efficiency on the water, but the safe, reliable passage of the actual human being operating the vessel.
And as it turns out, the student happens to be visiting for a deeply historic moment. Knowing his retirement is right around the corner, Joseph builds his final wooden fishing boat. You can just feel the emotional weight of this event. The entire village gathers to watch the launch. It's not just a commercial transaction. It's a profound community event. Children are decorating the wooden hull with flowers. A priest steps forward to offer blessings. And as the boat gently touches the backwaters, this massive applause fills the shoreline. The student realizes that in this village, an engineer isn't just some technician in the background. They are a central pillar of the community's survival and culture.
Section 5. Passing the hammer. Transferring generational knowledge.
So after the ceremony wraps up and the applause finally dies down, Joseph does something completely unexpected. He walks over to our young, modern marine engineer, and in his hand is his grandfather's wooden mallet. The handle on this thing has been polished completely smooth by nearly a century of human hands gripping it, swinging it, shaping wood, and he just hands it to her. It is the ultimate symbolic passing of the torch. It so brilliantly bridges the gap between the ancient tradition of the backwaters and the cutting-edge science of the university. He is validating her path, for sure, but he's also asking her to carry forward the spirit of the craft.
And as he hands her the mallet, he gives her this piece of advice that just hits right in the chest. He says, "Never build a boat just to float. Build it so someone always finds their way home." This is the absolute crucial takeaway for our student, and honestly, for anyone checking out this explainer. True marine engineering, or really true design of any kind, goes way beyond basic functionality. It's not just about creating the minimum viable product. It is a sacred responsibility to human life. It's about safety, reliability, and deep, deep care.
Later that evening, as the sun is setting over the Arabian Sea, Joseph sits quietly on the empty dock, just watching his final creations sail toward the horizon. He turns and shares this one final revelation, which fundamentally changes the student's entire perspective on her future career. He says, "People think I built boats, but all my life I built the courage people needed to cross uncertain waters." He wasn't in the manufacturing business at all. He was in the business of enabling human bravery. He gave fishermen the physical tools they needed to face a terrifying ocean and feed their families. Which brings us to the end of our explainer today, and honestly leaves us with a pretty powerful, lingering thought. Our student left that boatyard completely transformed, realizing that her equations and her blueprints are ultimately meant to serve real people. So I want to pass this question directly on to you. In your own work, in your own daily life, if a boat's true purpose is to give us the courage to cross uncertain waters, what are you really building? Take a second to think about the true impact of what you do every day. Thanks so much for joining me for this explainer. I really hope this sparks some curiosity for you, and I'll catch you next time.